This is the intermediate math challenge from 2024, and we will probably do it super quick. Question 1. At the top is 44, at the bottom is -4. They divide to make -11. The smallest two-digit prime is 11, and the largest is 97. It's obviously not 99, and 97 is the next one to try. Just try a bunch of primes with it. It doesn't work, so therefore it is prime, and you get 86 is the answer for the difference between the two. Now, this triangle here is clearly half of this square, and now look at these two triangles. To work out this area, you would do a half times this length times this length, the perpendicular height. To work out the area of this white triangle, you do a half times this length, which is the same as this length because t is the midpoint, times this length because it's the height. That's the same calculation. So therefore, this area is the same as this one. So this is a quarter of the total area because it's half of half the area. So it's a quarter of the whole thing. Root 5 squared is 5. Root 12 squared is 12. 5 plus 12 is 17. And then you root it for root 17. This person has 7 grandchildren, and the youngest 3 have a mean of 6. That means their ages are 5, 6, and 7. The oldest 3, now there are 7 of them, be careful here. So the oldest 4 are 8, 9, 10, and 11. Of the oldest 3, the mean is 10. 4 of these points on a line are circle. Now this is just, this point is 5 away from the origin. This point from Pythagoras is 5 away from the origin. So is this one, so is this one. This one isn't. And so that's the thing that's not on the circle. 25,000 cans of rice are made from 1 ton, and each ton contains this much. So all we have to do is 50 million divided by 25,000. You can cancel out the 3 zeros for each, and then it's just 50,000 divided by 25. 50 divided by 25 is 2. Add the zeros to get 2,000. 999 times 999 plus another copy of 999 is just 1,000 lots of 999, which is that. Now, each of these sectors have perimeter 18. Except this sector is missing this length. But that's great because this is a regular hexagon. So this length can just go here, and this length can just go here, and this length can just go here, which means the perimeter of this shape is just 3 of the sectors because each length has just been moved somewhere else. So 3 times 18 is just 54, and that'll be our answer to this question. Question 10, simplify these down first to save yourself doing annoying maths. 25 plus 24 is 49, and then times those together for 30, and we get the answer. This question here, so we've got 2 bars, each worth 4 times 80. We've got a total square, which is 80 times 80, which is this. We've got 2 bars worth 4 times 80, and then this bar is only 72 high because of the 4 here and the 4 there, and the 80 in total. So it's 72 times 4. We just have to assume because it's 4 centimeters wide, I guess. Now, I'm not going to calculate any of this. I didn't even do this here because all I need to do is do this thing divided by this thing. And I'm going to do some clever cancellation. So factorize out the 2 first. And now factorize out the 4 that's being times to make an 8. 8 divided by 80 is just a tenth, so we can get rid of that. Now 80 plus 72 is a bit like 80 plus 80, which would be 20 lots of 8. Except it's not, it's 80 plus 72. So that's actually 19 lots of 8 on that logic. Now this 8 can cancel with this 80 in the same way. This makes 0.19, which is 19%. So just some clever maths to make sure I don't actually have to do any maths. 1 squared plus 1 squared is 2, so this length is root 2. Root 2 squared is 2, plus 1 is 3, so this is root 3. This will be root 4, root 5, root 6, root 7, root 8, and root 9, which is 3. Increase the number by 20%, so that's going to be 1.2 lots of x by decimal multipliers. I get twice as much, so equals 2 lots of, decrease 20 less than the number by 20%. Decrease by 20% is 0.8, and 20 less than the number is x minus 20. So this is the algebra we need to set up. Let's expand this out, and we get this. This is just 1.6 times 20 is that. Just 16 times 20 and move some decimals around. Take this away, add this to both sides. I think I divided this by 4 and then times by 10. Answer is 80. Something like that will do. Okay, so firstly, angles in a quadrilateral add to 360. So we add these up for 30. 360 divided by 30 is 12. Times all these by 12 to get this. And now what we notice here is that this and this make 180. And this also make 180. None of them are the same, so it can't be a kite or a parallelogram. Kite has opposite the same, so does a parallelogram. It doesn't have a right angle, obviously, so they're all out. What about these 2 here? Well, trapeziums do have 2 angles that add up to 180 and 2 over here as well, because they're co-interior. Cyclic also have 2 angles, this time opposite, that add to 180. So which one is it? Well, it's the fact that it's going clockwise around is this. So this is going clockwise around in this order. So 72, 84, 96, 108. And we can see that if we do that, that works, I think, for a trapezium, but not for this. For this, going clockwise means that these two would have to add to 180, and so would those two, and they don't. So it only works for a trapezium, so therefore the answer is trapezium. We've got a few simultaneous equations we can set up here. So C plus B is 4,000 plus R. B plus R is C minus 2,000, I guess we could say that, and then the last one as well. What's the weight of Raleigh? If you notice, if you just add up, is it adding up this one and this one, the first and the last? Is that what I did there? No, the second and the last. If you add up these two, yeah, if you add up these two, the B's and the C's will just cancel because they'll be both on same sides. So you just solve for R immediately. There's lots of other more complicated ways of doing it, but that's the easiest. You actually didn't need the first line of information, which is kind of interesting. Got some factorials here. What's that when divided by 5? Well, that has a 5 in it because it's 5 times 4 times 3 times 2 times 1. And that has a 5 in it because it's 6 times 5 times 4 and so on. The fact that all of these have 5s in means that they're irrelevant to this question because they're not going to provide any remainder when divided by 5 because they're all multiples of 5. And we can just calculate these things. 1 plus 2 plus 6, this is, plus 24 makes in total 33, which has a remainder of 3 when divided by 5. 3 squared is 9, so this is 4 to the 9. Now this, you multiply the indices to make 4 to the 6. And then 4 to the 9 divided by 4 to the 6 is 4 to the 3. 4 times 4 times 4 is 64. So that's the answer to that one. This question actually took some time. I had a rule here, which was I wasn't allowed to write anything down for this paper here, because obviously otherwise IMC is a bit easy. And this is the first one where I had to break the rule. I just couldn't do this in my head. Anyway, 1, 4, reflection in the y-axis goes to, sorry, minus 1, 4 goes to 1, 4. And then reflecting the line y equals x. When you're reflecting the line y equals x, all you do is you swap the x and the y coordinates over. So it becomes 4, 1. You can draw yourself a little kind of triangle to show that if you want to. Get some squared paper and do that. Just draw the line y equals x, and then do a cross down, and then down across or a cross down there, and you'll just do the reverse thing, and you'll always get to that. Anyway, reflected in the x-axis becomes this, and we're looking for the area of this shape here. I decided to put a massive box around it like this, and say this coordinate and this coordinate are clearly just minus 1 down there, and 4, 4 up here. So the area of this box is just 5 times 5, which is 25. Now these lengths are 3 and 3. So the area of this little triangle is a half times 3 times 3, which is 9 over 2. And the area of this triangle is a half times 5 times 5, which is 25 over 2. Like I said, the whole area is 25, so 25 minus this minus that will give you 8 in total, because this is like 12.5 and this is 4.5, which make together, I guess, like 17, and then you take them away for 8 or whatever. Cool. So the columns, the rows, and the diagonals all times to make the same thing. So this times to 6x, which means this must also times to 6x, which means this must just be 1. And then we think about this diagonal, and if we just call it y maybe, we have here, and if we call this one z, that 18y and 12z must also be 6x. Divide both sides by 6, and you get this. Also, I could say yz times 1 is 6x as well from that row. And okay, so divide those both by 6, and then I think what I did was just times these two things together to make this. And now yz is 6x, so replace that in there to get 36x equals x squared. And then, of course, you can solve this. X isn't 0 because they're apparently not 0. That means 36 equals x, or just 36 times 36 equals 36. Right? Anyway, x is 36 for sure, and we'll be done. 3 for the price of 2, equivalent to saving this on each t-shirt. So we're buying 3 t-shirts, so we're saving £5.50 times 3. So we're doing that much of a saving. So okay, well, but we're also just saving the price of 1 t-shirt because we're buying 3 for 2. So this here just must be the price of 1 t-shirt. So using the special offer, what's the cost of 3? Well, you're only actually buying the cost of 2, so it's just this times 2, which is 33. 21, draw a box like this is the way to do this question. Because, I mean, side of 4 all the way across means that these lengths here are 2. So 2 squared plus 2 squared, square rooted is root 8, which you could write as 2 root 2 if you want to, but I just think I left it as root 8. The area of this square, therefore, is root 8 times root 8, which is just 8. And now we just need to take away all of the sectors that we get here. Now, I could argue that all of these sectors are 90 degrees because this is a square, but I actually don't need to. They could all be different. It doesn't really make a difference because by symmetry, they all must just add up to 360, all of the angles. So however you're shaking it out, these just must make a full circle in total. And each one has radius. What is the radius of each one? Root 2, of course, because I said root 8 can be written as 2 root 2. And of course, each of these is half of that. So this radius is root 2, just half of 2 root 2. So therefore, we just need to do pi times root 2 squared, because that's all four of them making a circle, which is just 2 pi. So therefore, the answer is just 8 minus 2 pi, which is E. Good. Now, so okay, you take a cube. I hate these kind of questions, but okay, if you sort of cut just a corner off of it, that corner has 1, 2, 3, and then just a face that's diagonal, which is 4 faces. So just imagine shaving just a corner off of this. 1, 2, 3, and the fourth is the diagonal face in there. So you can definitely do 4 faces. Can you do 5? Well, you can if you just cut a prism out of it, because the prism has 1, 2, 3, 4, and then the back face as well for 5. So you can cut a prism out and you get 5. You can definitely do 6, because if you just cut through the cube, you make 2 smaller cuboids, and cuboids, of course, have 6 faces. And you can also do 7, because going back to the example we had before, if you cut this kind of 4 shape out of it, what do you leave behind? Well, you leave behind a shape that still has this face, this face, this face, the back face, the bottom face, and the side face, plus the diagonal face in the that you form when you cut out this corner, and that's 7 faces in total. So the only thing you can't do by deduction must be 8. Next question. So AP is the same as PO. This length here, the moment you're doing a ratio question in UKMT, just make up a number. Make up 1, which means this length is also 1, which means if I call the radius of the smaller circle x, this length here from P to 0, or P to O, is 1 minus x, because this whole length is 1. It's the radius that I made up. Good. Now we can drop a radius down to the bottom here, which is also x, because of course the radius of the small circle is x. And now we can just do some Pythagoras. This length is a half by symmetry, so we can say x squared plus a half squared equals 1 minus x all squared. Do some expanding out. Remember, this is 1 minus x times 1 minus x. The x squareds cancel, which is nice. You get x is 3/8, which means the answer is 3/8 to 1, which is the ratio of which is the length of the big semicircle that I made up. Of course, times both by 8, you get the ratio of 3 to 8. The last 2 questions here. So apparently this area is a quarter of the total thing, which means obviously we've got another quarter over here, and then we've got 2 halves down here. So we have equal area, equal area, equal area, equal area. So that's the setup. If we call, again, it's a ratio question, so just call this length 1, and let's call this length x here, and we'll aim to solve for x. Now, if this length is 1, then so is this length. So this total length across here is 1 minus 2x. And I can now think about the perimeter here. The journey that one person is going to make is going to be x plus 1 plus 1 plus x. And the journey the other person is going to make is 1 minus 2x plus x plus 1 plus 1 plus x plus 1 minus 2x. That's just written here. Simplify it up, and you get this here. Divide by 2, you get this here. So I haven't made any attempt to solve for x yet. I've just described the ratio that is ready to be substituted in for x when I solve x. So I'll just leave that there. Now let's actually solve for x by thinking about these areas then. So the area of the big middle rectangle is clearly just 1 minus 2x times the height. So let's work out the height. So the height here, down here. Now, there's lots of ways to do this. Hexagons are great because they're just a bunch of equilateral triangles, all obviously angle 60. So this entire angle here is 120, just because it's two equilateral triangles next to each other. I decided to do some cosine rule at this point and say h squared was 1 squared plus 1 squared minus 2 times 1 times 1 times cos 120. I'm comfortable doing this because I just know cos 120 is going to be minus a half, which just makes this a plus 1 at the end, which makes h root 3. If you're not so comfortable with that, again, doing some triangles and just doing a load of Pythagoras also works perfectly fine. I know cos of 120 just because it's the same as cos of 60, because the cos graph is symmetrical around 90, except for a minus. But yeah, just draw the cos graph if you're unsure, or just do Pythagoras. There's lots of Pythagoras you can do that will also get you the answer. Anyway, h is root 3, which makes the area of this middle bit 1 minus 2x times root 3. And now the area of this side bit is just x times h, which we've already worked out is root 3. So that's just going to be root 3x, this strip here. Plus, and now here I'm going to do half AB sine C, because I also am comfortable with the fact that sine 120 is root 3 over 2, which makes this whole thing root 3 over 4. And now I'm actually doubled all of that, because I'm just going to say that this whole thing is equal to both of these sections. So I've doubled it, and now I can say this thing is equal to that thing. And this will allow me to solve for x. So let's expand that out, group that to one side, and put this over here, times everything by 2, I guess, divide by 8, and the root 3's cancel, and you get x as an eighth, which means now we can put this into this formula here. 1 plus an eighth ratioed with 2 minus an eighth gives you this, and then cancel the 8's, divide both by 3, you get the answer of 3 to 5. Quite a difficult question. I thought it was probably the most involved question on the paper, although there's probably much easier ways of doing it. I just had to throw in an edit here because this slide was animated completely wrong. But anyway, gold coin, we'll call it G, is worth X% more than a silver coin, which we'll call S. So X% more, well, if it was 5% more, that's 1.05. But how do you actually get that? Well, it's 100 plus 5 divided by 100. So for an X% more, it's 100 plus X divided by 100. So G is 100 plus X divided by 100 times S. Likewise over here, for Y% less, that's just 100 minus Y over 100. Like 5 goes to 0.95. So that's going to be this here. You can put this expression for G into here to get this expression. Cancel the S's and times everything by 100 twice, and you'll end up with this. Now, what does this say? Well, it says 10,000 is this thing times this thing. And these things have to be whole numbers because Y and X have to be whole numbers. So therefore, all this is just 2 factors of 10,000. And this factor has to be less than 100 because Y is positive. So basically, all this question is now is how many factors of 10,000 are there under 100? That's the entire question, right? Because if these are under 100, these will definitely be over. And finding the number of ways to do Y is the same as the number of ways to do X. So all of that's fine. So how many factors are there less than 10,000, less than 100 of 10,000? Well, we can do the obvious factors, right? If we set Y to be 99, then we'll get a factor of 1, which is fine. We'll have to set X to be some massive number, but that's completely acceptable. If Y was 98, we get this factor. These factors are also quite obvious. Now, how do we get the other ones? Well, think about the prime factors decomposition of 10,000. It's obviously 100 times 100, and 100 is 2 squared times 5 squared. So basically, from here, I can make any factor that has up to 4 2's and up to 4 5's. Which actually means I've missed a factor, right? 8 is a factor because it's got 3 2's, and so is 16 because it's got 4 2's. 20 is quite an obvious one I can take. That's 2 2's and a 5. 25 because that's just obviously 2 5's. Next would be, I think, like 40, I think I can make, because 40 is 8 times 5, which is 3 2's and a 5, and I have enough for that, so 40 I can make. 50 and 80 I can also make by the same logic. That's just 4 2's and a 5. 100 is too big, don't know why I wrote it, because Y can't be 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those, and so the answer is 12. Thanks for watching. I'll see you next time.